Hey guys, Shashank Kalanathi here, and on this channel we teach you how to break into the world of data science and data analytics using real-world examples. And one question that I often get from people is, what is a good portfolio project? Basically, what is a portfolio, and what would be a good project in a portfolio? I always tell people that the best portfolio projects are basically questions that you already have about the world, and using data to solve those questions using either Python or R or SQL or Tableau. I generally use Python. One question that I had was, what is the best day to invest in the stock market? Now, a little bit of ground information over here. So I'm very much a buy and hold investor. I basically will buy a whole market ETF, usually VOO, which is Vanguard's way to track the S&P 500, which is the 500 biggest market cap companies in the United States, with a couple of exceptions. It's actually a little bit more than 500 companies. And basically, the general idea is that if you just invest in this, your gains will be at about 8% per year, give or take. And I think actually these days the gains are closer to 12% per year. But I usually receive my paychecks on Fridays. I receive them once every 2 Fridays. And then I just have M1, my brokerage, auto withdraw from my paycheck and put it into my account. But I wonder if there's a better day than Fridays to invest my money. Now, this idea came up because I was watching a video where they talked about this thing called the weekend effect. The basic idea behind it is that stocks tend to trade at lower values on Mondays versus every other day of the week. And so I was like, okay, well, I can go ahead and download some VOO data and then test it out myself and see if not only is this true, it's the effect is listed on investopedia.com, but I can test that myself quite easily. Not only if it's true, but also test to see if maybe we can improve on it a little bit by using some forecasting techniques.
Spoiler alert, I actually don't improve on it at all. My forecasting techniques did not work at all, but it was a great lesson and I got to learn how to use a library that I was not aware of before. As a little bit of a disclaimer on the side, trying to predict the stock market is a very, very difficult exercise, and it's something that people who are way smarter than me spend their entire lives trying to do. So I didn't come into this expecting to come up with any new knowledge, but what I thought, was that this would be a great opportunity for me to test out some libraries that I've been wanting to test out for a while, namely Facebook's profit forecasting library, and just to flex my Python skills a little bit and show you guys what I mean by kind of answering your own questions when you're deciding to do a portfolio project.
Now, those of you who are longtime viewers of the channel will know that I've been wanting to improve my production quality for a while, which is why I was so glad when this week's sponsor, Skillshare, reached out. Skillshare is an online learning platform with thousands of videos made by some of your favorite creators from MKBHD to Ali Abdaal that teach you all kinds of skills from how to do photography to making better YouTube videos to better videography to even just how to improve your mental health. There were 2 classes that I took that I personally like quite a bit. I took MKBHD's YouTube Success, Script, Shoot, and Edit with MKBHD, which was a tremendous class on basically MKBHD's process for making interesting videos for his audience. So the one part that he talked about that was quite interesting was the introduction, and how the introduction of your video is the most important thing and the thing that you need to spend the most time on in order to perfect and do better. So you'll see I'm going to be experimenting with a couple of different types of introductions over the coming weeks to see how I can get better retention rates on my audience or on my videos from my audiences. The second video was Fundamentals of DSLR Photography by Photo Essentials by Justin Bridges. I'm still in the middle of this one, so I can give you guys an update a little bit later. But as you guys may know, I'm now in Seattle, which is in Washington State, which is just a beautiful state. And I have this nice camera. It's a Sony a6100 that I bought for the YouTube channel, and it came with well, it didn't come with this lens, but I bought one of these telephoto lenses in order to kind of fix one of the deficiencies of my phone camera, which is that my phone camera can't really zoom in all that much, right? So you'll see it expands like this. So I want to learn how to use these lenses better to take better photos, which is exactly why I'm taking the Justin Bridges course. So far, I've been very happy with the service, and I'm going to be happy to use it for the next couple of months in order to actually try and pick up some hobbies on the side. Anyone that's a long-term viewer of this channel also knows that I need to pick up some hobbies outside of just YouTube and work and stuff like that. So I'm hoping that photography can be one of those things, and then maybe I can find another 1 or 2 on Skillshare as well. So if you're interested, the first 1,000 people to use the link in the description below will get 1 month free, a 1 month free trial of Skillshare using the unique tracking link that I have in the description below. So thank you so much to Skillshare for sponsoring this video. All right, so let's get right into the data. So first I'm going to go over the 3 different methods that I decided to use. The first method that came to mind when I was trying to decide which day would have the biggest dip in values, in stock values, that way I could buy stock at a low price, was method number 1, which was the average dip per day, where I basically calculated the difference in stock price from Monday to Tuesday, Tuesday to Wednesday, Wednesday to Thursday, Thursday to Friday, and Friday back to Monday. And I did that for every single day. And by doing that, I could then calculate the average dip per day over the course of time and average that out and say, okay, it looks like stocks go down the most on this day. The second methodology was what I call my backtesting method, where I basically pretended that I invested the same amount of money every single on the same day every single week for basically the 12 years in which I had data, so from like 2010 onwards, and then saw which ended up with the highest account balance at the end of the 12-year period. And the third method was I would take 3 weeks of data and then try and predict 1 week of data the 1 week afterwards using that three weeks of historical data. And this was using Facebook Profit. Now, this method proved not to work at all, but it was an opportunity for me to go ahead, use and test out the Facebook Profit library, which at the end of the day, when it comes to portfolio projects, not everything works out exactly as you need it to or as you expect it to, and that's okay as long as you can make a very good explanation and there's a good story to go with what you did, and you really did put a good effort into trying to get things to work. But for the sake of this project, no, it didn't work out very well. So as we're getting started, the first thing is, where do we actually get the data from? So if we go to finance.yahoo.com, you'll see under quote the ticker symbol of your stock /history. It will show up over there. You can just click on this download button and you can download a CSV. So we've gone ahead and done that. Whoops, that is my editing rig. So we've gone ahead and done that. Let's go to the code and see what we can do. So first things first, we're going to go ahead and import pandas. Pandas is PD. That's our library to manipulate tabular data, aka our CSV. Then we're going to go ahead and import Profit. So Facebook Profit is the library that we're using in order to do our forecasting method, which is method number 3. And then I want to go ahead and import this thing on clear output. So the Facebook Profit library, whenever you run it, it outputs a lot of logs into your Jupyter Notebook, which they sometimes get in the way. So this allows me to clear those logs because I've already read them and I don't need to see them anymore. Then we're going to import OS. That way we can access our files more easily. Logging will allow us to further manipulate the output of that Facebook Profit, those logs. Then we're going to go ahead and do logging. So from this logging thing we imported, .get logger profit, so get the logger for the profit library. And then we're going to set the level of the logging to warning. And basically what this does is this removes the info warning type from profit. It's not an important step, but basically it'll reduce the size of the logs that appear at the bottom of our cells. All right, so let's go ahead and read our data. So I'm going to go ahead and do my standard pd.readcsv, VOO.csv. And we're going to parse dates, right? And we're going to parse them to be the date column. Whoops, I did not actually run this yet. Run my imports. Then we run that, and it looks like we have our date, open, high, low, close, adjusted close, and volume. Now, the only column I care about in reference to price, right? So these, 5 columns over here represent the price of the stock on any given day. The only one I actually care about is open, as that is the brokerage I use is M1 Finance, which only trades once a day near the opening of the market. So I'm just going to use the opening price as the price to use in my methodologies. So we're going to go with the opening price. Next, I want to add a day of the week to each of these columns. So for example, what day of the week is that? Let's go ahead and create a quick little method to do that. So I'm going to go ahead and create this dictionary called Day Mapper, where 0 equals Monday, 1 is Tuesday, 2 is Wednesday, 3 is Thursday, 4 is Friday, 5 is Saturday, and 6 is Sunday. And you'll see why we do that in a second. We're going to go ahead and create a new column called Day of Week. And we're going to say that equals the date, and we're going to map this dictionary that we created to a lambda function. Remember, a lambda function basically allows us to perform a function on every single row of the data set. Day mapper x, so x is each of these values here, dot day of week. And if you do day of week on any of these values over here, it'll give you a number for the day of the week that this represents, in which where Monday is a 0. And then let's go ahead and check it out and see what we get. So it looks like our first value, 2010-09-09, is a Thursday. Let's go ahead and check and make sure that that's actually accurate. Let's see, we'll do Control V, day of week. And it looks like September 9th, 2010 was in fact a Thursday. So we did do our mapping correct. Looks good, looks good. Awesome. So now we have gone ahead and made sure that this data is accurate. So that's great. So let's go ahead and do our average dip per day method, and see how well it works. So we're going to go ahead and create a column called diff from previous day. And all it is it is data import open. So we're taking this open column over here, and we're doing .diff, which will basically take the difference between the current column and the previous column. And then we're dividing that by the current open price. So by doing that, what we're doing is we're able to say, okay, what is the increase from the previous date to today? And then multiplying that by 100. So just to make sure we do this correctly, let's actually go ahead and split this step into a couple of different things. So actually one thing I want to check is, what exactly does this diff do over here, just to make sure my logic is clean? Whoops, so we'll do actually we don't even have to do that, we can just run that. So the first value is negative 8.82, which would be, yes, that means that from here to here, we've gone down by negative 0.82, then this one should be positive then, right? And it is 1.279. So in that case, this is the relationship we're looking for, because we want it to be negative going from this. If the previous day is higher than the current day, then we want that value to be negative. That way we can see the dip in values. So awesome, that's exactly what we're looking for. So divide that by the open price and then multiply by 100 to get a percentage. And then let's go ahead and check out what that does. And as you can see, yep, that seems to be about right. Yeah, this would be about 1% over here. Yeah, that makes sense. And then 1.25. Cool. So now let's go ahead and see how this looks per day. So what I'm going to do over here is I'm going to take the day of week. I'm going to group it by that, right? So the day of week is Thursday, Friday, Monday, whatever that is. So we're grouping by those values. And then we're taking the diff from the previous day. And I want to take the mean across the last 12 years and see what we get. So let's see what this does. And it looks like the biggest average dip happens on Monday. It goes down on average by negative 0.03%. So not that much, but maybe over the course of 10 years, that actually adds up to quite a bit. But this seems to actually support the whole weekend effect thing that is a very well-known effect in finance. So that is, I guess, good to know. We haven't really disproven anything, but again, we were able to test it out. So that's one method. We take the average dip across the last 10 years between the 2 days. Now let's use a fairly more robust method where I literally pretend I invested in every single week on a given day for the last 12-ish years. So what we're going to do is we first need to create a table of every day between the minimum date and the maximum date to deal with holidays. So what happens is the stock market's actually closed quite a bit. On many days it's closed. And so for example, say Christmas falls on a Monday, right? Stock market's closed on that day. I think it's open on the 26th, but the basic point is if I was going to put in my trade on the 25th of December, now I'm going to go put it on the 26th of December. So I need to be able to deal with those values. Because if I don't deal with those values, then I might accidentally create a backtesting algorithm. And backtesting is the name of this methodology, basically. If I don't have something to deal with the holidays over here, then my algorithm will actually just skip over weeks with holidays on it. So we don't want that to happen. So let's go ahead and create a table, or not a table, but a range called dates, which uses the pandas date range method. And what it does, it'll take the minimum date from our table and the maximum date from our table and create a range of values one by one, day by day. And then we're going to create a data frame with that where this will be the first column and we'll call it calendar date. And then weekday will be the next column and it'll be the same little lambda function we had up here where we just wanted to turn dates into weekdays, or the names of the days. And then let's see what this looks like. Awesome. So it looks like we have every single value and every single value, we can go up from there. kind of to illustrate my point, I guess let me show you guys what exactly I mean. So let's go ahead and do the data import, and then we'll do to clipboard. This is one of my favorite methods. So I run that, and then what I do is I usually open up a quick Excel file, and I can just paste the data in there. And if we go down to December 25th, you'll see from the 23rd to the 27th, there are no values. The stock market's just closed for all those days. So we have to make sure that we have we have something to trade in this time period. And that's why we need to deal with the missing values in between these two. So so what I did is I did the to clipboard method. And what that does is that basically that'll paste this data frame in my clipboard, and I can just paste it in Excel pretty easily. And because this data frame is so small, that was a very useful technique. All right, so now I'm creating a table called full calendar, which is going to combine, it's going to join, it's going to merge, it's going to join the date table, which is what we just created, that's this table over here, with the data import table, which is the table we've been using with all the pricing information inside it. We're going to do a left join, that way we can make sure to include every single date, which is available in the date table, but not all dates are available in the data import table. And then these are the indexes that we will, sorry, not the indexes, the columns that we will join on. Calendar date from the calendar table, or from the date table, and date from the data import table, from the price table. Then what I want to do is I want to make sure that I get rid of any Saturdays and Sundays. Stocks will, I'm never going to trade on those days because, you can't, right? So what happens is this table includes Saturdays and Sundays, as you can see, and we want to get rid of those values because we're never going to trade on those days. So what I do is I do this regular filtering method where I do full calendar weekday dot is in Saturday, Sunday. So is it in Saturday and Sunday? And then this little line over here reverses the operation that that is in front of it. So we're basically saying is in, get rid of that stuff. So little technique I learned. Next, we're going to go ahead and rename the date column, which comes from this table over here. You'll see it's called date. We're going to name it to trading day, just so it's better named. In place equals true just means that we go ahead and we implement that change then and there, and then let's see what we get. So if I ran that, it looks like we have the calendar date, we have the weekday, we have the trading day, which is very useful. The open, high, low, close, adjusted close, volume, day of week, and then difference from previous day. Awesome. Sweet, sweet. So this is exactly what we were looking for. So in order to account for holidays, we need to take the next day's opening value, as that's the price I'd buy the stock at. So right now, I can show you guys. So let's go ahead and do full calendar to clipboard. Let's go ahead and run that, and then we will open up an Excel file. All right, let's see. Here we go. For example, there are no values over here, right? So what I want to do is I want to bring in this value over here, because if I put in a trade on this day, then it'll just the brokerage will just trade on the next available day. So this over here needs to be taken care of by backfilling this value in here. So we're going to be using the bfill method, which stands for backfill, and we'll basically take the next value and pull it up to the value you're worried about. So let's go ahead and do that. So what we're going to do is we're going to do full calendar.bfill, because I just want to do it for all the rows. The axis, we're going to make sure it's rows. That way it doesn't do it for columns. We're going to reset the index and then drop equals 2. And then let's go ahead and run that and see what we get. Looks like I have to do an Excel file again to show you guys. Again, this to clipboard thing is too nice. Sometimes it's just easier to explore your data in Excel. Okay. Yes, so you'll see these two values are the same. So if I was going to trade on this day, then the actual trading day would be the 26th. So remember, if we go up here, let's go ahead and bold that for you guys. And then probably zoom in a little bit too. And then let's go ahead and use view, freeze panes, freeze top row, and then we'll go back down here. And you'll see over here, that the 24th to the 26th, the 25th had no values in it, right? So what happens is the calendar day is the 25th, but it'll actually trade on the 26th, and we bought in data from the 26th. So that's what backfill does. All right, awesome. And then let's go ahead and test. Awesome, so this looks like we have the same number of weekdays every day, we have the same number of weekdays across our 12 years of data. That's perfect. So this means that our testing will actually be pretty accurate. So now I'm going to go ahead and create a function. What I'm going to do is I want to do a for loop where I loop through each of the days, Monday, Tuesday, Wednesday, Thursday, Friday, and I basically simulate trading every single week for 12 years to see how much money I get. And I'll trade a certain amount, let's say $750 a week. So we're going to create a method, or we're going to create a function called day backtester. We're going to be using the one of our parameters is going to be called day, which is what day we are going to be filtering down to. The amount to invest, which is basically what amount are we going to put in every week, and then the data, which is basically the data table we're worried about. So we're going to create a little mini table called temp data where we filter it down to just the days that matter. So for example, we'll take this full calendar table and then we'll just filter down to Thursdays or Fridays or Mondays or whatever. Yeah. Then we're going to create a column called shares owned, which takes the amount to invest and then divides it by the opening price on that day. And so, if I invest the exact same amount over 12 years every single week, then obviously I'll be buying fewer and fewer shares as time goes on, which is not really a simulation of what I would be doing, but it's good enough for our purposes because presumably my income goes up and I would invest more as I get older. So, but it's good enough for the strategy or for what we're trying to test out. Then we need to determine what the final price is because eventually I want to see what the end value of my brokerage account is. So the final price is just the temp data, the open column, .ilock -1. So what this does is this will basically get us the last value in the in the open column. So what would happen is if I used it on this table over here, it would do -1, count from the bottom, and get this value over here, 408.20002 or 12. So we have that. Then what we're going to do is we're going to calculate a final amount, the actual value of my brokerage account, which is temp data, shares owned, which we calculated up here. We're going to sum that and then multiply that by the final price. And then we're just going to format it. This is basically how you format stuff to a $sign. You do this .format final amount. And then we're going to return that over there. So let's go ahead and run that. And then let's create our for loop. Our for loop is basically going to say for I in full calendar weekday .unique. So what this is going to do is this will actually output a list of every unique day. So we're going to iterate through that. Print I, so I would be the day of the week we're concerned with. And then day backtester, that's this function we created over here. I 750 full calendar. So I is the day of the week that we care about. 750, I'm going to invest $750 a week every week. And then full calendar is the data table we're going to be using. So let's run that. And as you can see, it looks like by using this method, actually Thursdays, investing on Thursdays gets us the most money over time. Does that make sense? Well, that would disprove the weekend effect for our purposes, but it looks like Thursdays are actually the best days to invest in. Okay. So this is interesting. This is an interesting development over here. So over the past 12 years, if we were to invest every day on a Thursday, it actually looks like that the Thursday is what we would really care about. And maybe what I need to do is I need to try this with different stocks I'm interested in and see if there's like a different value depending on the stock. All right. So that's some interesting information over there. And the final method is the Facebook profit model, right? And this one, I'm not going to write the code out for you. And the reason I'm not going to is because it's a very computationally intensive method. So I can't actually run it and screen record at the same time. Or let me rephrase it. It takes hours to run. That's probably the better way to do it. So there's probably a better way to run it than what I'm doing right now. If anyone has any better suggestions, leave them in the comment section below. That would be extremely helpful. So we're going to do def profit predictor dataset, m equals profit m dot fit dataset. Oh, so what we're going to do, we first need to instantiate a profit object, and then we're going to fit it to our dataset. It works like an sklearn function. And then we're going to make a prediction for 7 days. So basically the next week. And what I wanted to do is I wanted to take the prior 3 weeks of data, so Monday through Friday, and then on the following week, determine, okay, which day of the week has the lowest value on average, and then predict that, and then return the forecast. So we went ahead and did that, and then we created this actually wasn't used for anything, I think. Yeah, we ended up getting rid of this because it was just, it was too slow to append a bunch of data frames to each other. So what I did over here is I basically created a bunch of pickle files. Did I do that here? Yeah, 2pickle of the output. So what I would do is I would take a 3-week block of data, put that into the profit model using this function over here, and then get an output. Oh, and you know what? Sorry, yeah, I can actually show you guys exactly what it looks like over here. Down here. So using the profit model over here, yep, this is exactly what it looks like. So we are able to take the individual values. Sorry, so we take a three week block, right? So we take 3 weeks of data, we put it into the profit value, library, have it output something for us, or have it output a prediction of the next 7 days for us, and then just put that into a data frame. That's basically all that this stuff is doing. And you can check out the code over here more deeply as you want. And it actually created this huge list of pickle files that I ended up just appending together because it kept getting stuck in like C++ or whatever, crashed on my computer like multiple times, which is why I had to do it in sections. That's why I was saving files because I had to do it in sections. So then what we do is we go ahead and we append all the files together and we get something like this. Predicted date, prediction, y hat lower, y hat upper. Oh, sorry. Yeah, sorry. So, yeah, and these are entirely predictions. So these are all predictions of what we predicted would happen. And then what I want to do is I wanted to take the... I basically want, like, for every week that we had, I wanted to calculate the minimum value of that week. That's what this is. So we create this column called Week Monday, which is basically like what is the date of the Monday on any given week. Then we group by that Week Monday, and then we get the minimum prediction, and then we do a quick join back to the data. That way we can see which day of the week that actually was, and it ended up being Monday most of the time actually. And then we do the same thing for our actual values, like so the real data that we have. And then we go ahead and count them. And it looks like Mondays were the minimum day of the week most often. Thursdays were down here, which is why it really confuses me that the Thursday, if I invest on Thursdays, I got the biggest value on stocks versus any other day. Although I'm trying to think if there was some flaw in that methodology, the backtesting methodology. What might happen? What might have happened though is that over the course of time, Thursdays had the strongest dips and the strongest rises in value, which is why it may have evened out and created extra wealth on Thursdays versus Mondays in the backtester method. But over here, it looks like Monday leads to the lowest value on average. And then we do the same thing over here with predicted values. I'm not sure why this isn't showing a result. There we go. You'll see, again, we get Monday as well. It says there are more weeks had Monday as the lowest day versus anything else. Then I combine everything with just a simple join over here, and I drop a couple of the null values, which were the beginning predictions. And then basically what I wrote over here is I created a column where if the actual minimum day, so the minimum day in the actual data set, is the same as the minimum day on the predicted data set, as in like they both said Monday, for example, you would get a 1. Otherwise, you would get a 0. So, for example, if we predicted that Tuesday was the lowest day and Thursday was actually the lowest day, then we'd get a 0 for that. And then we just created a quick calculation of the sum of that column divided by the length of the data frame. And it looks like we were only right about 22% of the time. So that is not good. And that could be as simple as, for example, over here, We predicted that Monday would be the lowest day when it was actually a Tuesday. So, it goes to show you how you can't just run a simple forecasting algorithm and try and predict the stock market. Although I am curious to see if we adjusted this and edited it a bit more, if we could get this to work a bit better. And that kind of brings me to kind of like the conclusions of this video, where this was kind of just an example I was trying to show you of how you could use, you should approach your portfolio projects. I don't know if I would call this a full portfolio project. This is kind of just something I wanted to test out myself. What you would really want to do is you would want to add some like charts and graphs to this to make it a lot prettier. But because this was purely utilitarian for me, I just simply put together this code. And this is an example of like a good way of thinking about a portfolio project. I had a legitimate question I wanted to answer, and I used data to answer it because, I could. I read about the weekend effect on Investopedia, but we have the tools to test out ourselves. Why not do it? If you have the tools and the time to test stuff out yourself, you might as well, right? Some improvements that we could do on this method. I'm pretty sure that we could do more interesting stuff with that backtesting method. Like, what if we switch different days of the week? So we didn't always invest on Thursdays. We invested on like Monday, Thursday, or something like that. Or maybe we could try like a bunch of different combinations and see what works out the best. And then the Facebook profit model, I think, actually has a very interesting future, potentially, in a future video, where we actually try to improve it and make it better over time. So I think that there are a couple of things we can use to improve all of the stuff we're doing over here. And if you're doing a portfolio project, you should make sure to include a section of your video or a section of your presentation where you talk about potential future improvements. So thank you guys so much for joining me. I'm really glad. I really hope you guys enjoyed this. This is a bit of a shorter form video than what I normally put out, but I was just curious to see. I did this. And I was like, I'm pretty sure the subscribers would love to see this as well. Let me know what I did wrong. I 100% did something wrong, and I want people to let me know in the comment section below. Tell me how I can improve this, and tell me if you have any theories as to what we can do better. The notebook is available to download in the description below as well. I'm not going to leave the data set in there because you can just go get it from Yahoo Finance. I showed you guys how to do that earlier. But outside of that, if you have any questions or comments, please leave them in the description below or in the comment section below. Make sure to like the video and subscribe, and support creators like me by supporting our sponsor. Skillshare was an amazing sponsor for this video. So thank you so much, guys, and I hope you have a great day.